Today's topic number 1. A function belonging to yz where x, y, and z are Boolean variables and trust in logical OR operation that we know. Because multiplication denote this y dot z denote AND operation and x, y OR operation. Okay. They are asking this function is given which is x plus y, z, and they are asking following function given in ABCD is equivalent to this. So let's just solve them one by one. For A, if I for A, that x plus z plus xy. How we can the one way we can by using for this little length because it is a very solved by our Boolean algorithms. So you can see here x and x common. So take x here 1 plus y plus z. Okay, anything plus y according to Boolean algebra, it says that if you are adding any variable 1 that is equivalent to 1 only. So that will be x plus z. It is not same. So of course A is cancelled. For B says x plus y, x plus z. Let's just open it. It will give very interesting. So x dot x plus x dot z plus y dot x plus y dot z. This is brackets. Now anything we are ANDing it with itself like x dot x, it will be x only plus xz plus xy plus yz. Here taking x common from all the three. Get this. Now adding 1 to any Boolean algebra, that will give you 1 only. X plus yz. Now this is as associative law. How we can go this way also. X plus yz is by brackets x plus z. Okay, moving. Option C. Option C is x plus xy plus x, sorry, yz. I, option B satisfies it. Now opening it, taking x common again, 1 plus y plus yz. Here it will be x plus yz. So yeah, this also satisfies the Boolean expression. They both are same. Moving on to the last option. Option number 3, x plus xz plus x common, it will be 1 plus z plus y, that will be equal to x only. Yeah, only option B and satisfy. A and are not same. Okay, question. Okay, next question, presentation algebra. They are of product and product of sum. SOPs, sum of product. In these, we take 1 when we are drawing a case. Whichever value is 1, so this is A and B came up. This is B bar, this is B, this is bar, this is A. Here if I am writing 1, that will consider in SOPs form and it will be equal to A bar, B bar, and we will write it like this, right? A bar because it is here and B bar because it is coming in our K bar. we will write another type of form is POS. POS, product of, where wherever we will be finding 0 on K-map, that is represented in POS form. Sum of products was one term I'm taking here. So here A bar and B bar are the product, and if I have to take other 1 bits, so I have to take sum of these products. So other will be A, B. This will be sum of products, and if I am taking 0, same way in making came up. A bar, A bar, A, so, and we will be writing them in the way product of sums. Sums, product them when we are having 2 zeros at in one K map. So we will sum them. It will be A bar plus B bar. Now here we are talking about 0 priorities. Writing 0 like this, we will be writing it by this. Here 0 is written like this and 1 is written like A bar. In SOP's form, 0 is written like A bar and 1 is written like A. So in POS form, 0 is on priority. So that's why we are giving bar like this different number to ones, not zeros. So it will be 0 will be represented by A plus B. Dot, there is another term 0 and it is coming at 4. Right? So it will, if I will be writing it as 1, so it will be A, B, but here it will be written writing POS forms. Moving on to the question. When SOP, sum of product form and where. Okay, you have to find out the POS. In this case, we will see that what number they are. You have to find out the min terms. Okay, we have to find out the min terms. We take the bars as 0 and non-bar as 1. What? This is SOP of product is right. So this is bar, non-bar. What are the min terms? Min terms are 0 because 0, 0, 0 will be back, will be decimal 0, and 0, 1, 0 will be decimal, and 1, 0 will be decimal 4. Here, max terms to find out the POS forms, the opposite one. So opposite terms are known as, in POS we call those terms as max terms, and SOP terms as min terms. Okay, so they will be just opposite, just different. Right? The remaining terms, basically, remaining terms will be your max terms, and they will be 0 is there in min term, so 1 will be a max term, 2 is there in min term, so 3 will be, and 4 is there, so 5, 6, and 7, because it is a three variable Boolean function is given. So basically there will be 8 values. In 8 values, 3 are already provided, and they are asking all the max term or POS form. You have to write them in terms of POS. Like you can convert this directly in product into sum. You cannot write it directly like this, and so on. Right? You have to find out their max term. Have to find out the place value where zeros are present when ones are given, or vice versa when they are asking SOP. So you have to find out where ones are present when zeros are given. Now we have found out that at these places ones are given, the remaining ones will be left for zeros, will be filled with zeros. Suppose if I draw the K map of this, A, and this is, so it is A bar, A bar, where only one bit should, only one bit are. So now if I draw, so it will be 1. Okay, so 0, 1, it will be 1, and it will also be in terms will be filled with 0. So there are 0 number. They are 0, 0, 0, 0, 0 here. So this is 1, 3, 5, 5, 6, and 7. How we draw the K map? Now just write for this 0. So what will be, how will be writing this at 1? So here 0 is given priority, as I have told you. So this A bar will become A, plus this B bar will become B, and C will become C bar. So this is how you will be writing 1 plus, sorry, this is multiplied, this sum of this is a product of sums. So we are having sums, and we will be producting all the other terms. Okay, so this will be A plus B bar plus C bar, and we'll write number 5. So this will be A bar plus B plus C bar dot number 6, that will be A bar plus B bar dot last term number 6, that will be A bar plus C. Which option satisfy? And we can here like eliminate options very easy. Like if you have to opt from one of the option to like know it, because there are like 1, 2, 3, 4, 5 max terms. So this is 1, 2, 3, no. 1, 2, 3, 1, 2, 4, no. This term have 5 max terms. 1, 2, 4, 5. Option number C will be your correct option. Question. Okay, next question says that which of the following gives this for the Boolean function f, which m0, that is 0 is your 2 is your min term, 3 is your term, 5 is your min. Okay, corresponding A, B, where A is the most significant and C is the least significant, right? So they are asking you to find out the simplified Boolean expression. So let's just write these terms. A, B, C can write easy. So we have to write in terms, in what terms we have to write? It is in SOP. We can easily write. So 0 will be A bar, B bar, C bar plus 2. 2 will be A bar, B, C bar plus 3. That will be A bar plus 5. That A, B bar. How we will be writing 0, 2, 3, and 5. Now they are asking you to find out the simplest one. So after simplifying this, which will be the final result? So you can solve it by that we can find it in common. But sometimes people think like this is very like a time taking process. So best way is to like you can easily came up and solve it. Let's just try solving it by taking common, which you find common here. They just try using maps only. Try using K-maps. Terms will be and C. bar C. First term is A bar, B bar, C. So there will be one is A bar, B. This is one. The term is A bar, B. So this last term is A, B bar, C. So A bar, C. This is common. This is also we are getting common, and this is a separate term. The best way is to draw. Otherwise, we will be finding out common, and this will be a lengthier and time taking. So by using K-map, we can easily find out that what will be the prime implicant. Right. So now let's just see. So that will be term, first number, second number, and the third number. First number, A bar is common here. Right, how we find out the terms in a K-map. So we can see that A bar is common in this one and this one, right? And which one is which other term is common from B and C? So here B bar and B common, so C bar is common. So A bar and C bar plus. Now in this terms, let's just see which are common. So this and this. So A bar is again common. And here C and C bar are, so B and D is common. So A bar B plus the last remaining term will be, you can write it easily. So it is A bar and C. So which is the correct option? So correct option will be your correct option. You can also try finding out the common part, but both. Solve a large Boolean expression by using the commons and is not common. Okay. Next question, K-map is only given. So K-map is, they are asking, there are 5 variable K-map and minimum sum of product expression from the function is given. Now the 5 variable given. And this 5 variable, this is making a quad. Similarly here, this is making a quad. In there is nothing. Okay, so we can easily find out the quad. So this is RQ. This in this RQ, which is common. So this is 1 and 1. So S is common and S is 1. Take S. Now in these two, we check which is 0 and 0 is there. Otherwise 0 and 1 is happening. Complement started and 0 is there, and that represent Q bar because it was 0, and also it is X is equal to 0. So we will be taking X bar plus another quad. So another quad is here. Have to compare between these two. So it is 0 and 1. R is 0 and 1. So it will be S is 0 and 0. So it will be S bar. And here also you find out. So here P is 0 and 1 cancel out. Q 1 and 1. So X your right SOP expression. This function O R S and X. Option S. Your questions are really, so function of Boolean variable X, Y, Z is expressed in terms as X, Y, Z. Also some terms are given. 1, 2, 5, 6, 7 are the min terms. Of the product of some below is equal to the function. So similar kind of question is asked. Solve it. 5 terms are there. Now you cannot eliminate it directly from the option. So 5 terms are main terms. So max term 8 minus 5, that will be 3 terms. So there are like 2 options for 3 terms. So in this case, you have to solve it, and you have to find out the place values for zeros, and accordingly you have to write the expression for max term. They just draw the K map for this also. Okay, x, y, z, 0, and 1. So 1, this is place value for 0, this is place value for 1, 4, 5 place values. So we can fill up the K map by ones. So ones will, so here is 1, at 2, at 5, at 6, 7, and the remaining terms will be zeros. Zeros will be at this, and so you have to just now write down the expression. Now writing down the expression, so now 0, 0, 0. Again, this is, so this is x plus y plus this one, third one. So it will be x, y bar plus z bar. Last term will at number 4. So it will be x bar plus y plus z. Option is correct option. Option number B is your correct option. Zeros are not represented by complement. Zeros are represented by the exact variable, and 1 is represented by the complement. Okay, so this is how we write the QoS form. When this 0, 0, 0 was there, so it should be x bar, y bar, z bar. We are writing as we have to write the opposite first. Now, add f x y z equals to some converted into the QoS form. Again, the expression is given here, and you have to convert this its QoS form, and this work time form is given here. SOP form is given. Form is given here like this. Convert this into QoS. What you have to do is you have to find out the place values for 1. In the previous question, they made it little easier. They already told you the place values. Right? In this question, you have to find out the place values first, and then you have to find the zeros, the opposite place values, max term place values, and then you have to write the expression. They just find out the place values. So this is 0, 1, 0, 1, 0, 0, 1, 1. So the min terms is, so this is 4, this is 6, and max term we will directly write. Max term will be, instead of find the K, directly write the max term, the remaining, the leftover term, 0, 1, 3, and 5. These terms will be on max. Now you have to express the 0. So 0 will be x, y, z. So x plus y plus z. 1 will be plus y plus z bar. 3 will be x plus, and 5 will be, 5 is 1, 0, 1. So wherever the 1, you have to make a bar of it. So which one is similarly 3? 3 is 1, 1, 1. So wherever the ones are, you make them in bar. Option is satisfied. Okay, option number A is satisfying the max term. So these are the max term. So didn't find out the K map, directly found out the values. The max values were 0, 1, 3, and 5. And finding out the max values, we can directly write their QoS forms, like the way we write, or you can convert. Very difficult, easy job. Okay, moving on to the next question. The maximum number of prime implicants. So direct questions, maximum number of prime implicants is 2 raised to power n minus 1 r prime. So if I a K map, suppose like this is a suppose I'm writing here 1 1. So here prime implicants, basically when we are combining these ones and rectangular join or a square join, like whenever we are making a like a pair, this is pair, a quad, or 8 numbers together. So basically that is combination. So here we can see how many pairs. This pair, and this 3 pairs, right? 3 pairs we can see. So these are only on the prime implicants. 1, 2, and 3. These are 3 prime implicants.